So, good afternoon, everyone. I think in the yesterday's class, we are done with the FAQs of wave optics. Now, we are left with, even though this could be an extra question, we are left with LAQs from waves chapter. I will try to finish those LAQs. Now, most probably from tomorrow onwards, we are going to discuss VSAQ. Okay. So, let us start today's topic, that is wave. We'll be discussing the LAQs from waves. So first of all, I will discuss the LAQ of Doppler effect because already we have studied regarding Doppler effect of light. What was the definition or statement for Doppler effect of light? When the apparent change in the frequency of light due to relative motion between what? Source and observer. So, but here in waves, we'll be studying about Doppler effect of sound. Let us understand that. See, the first question that we are going to discuss today is Doppler effect in case of what? In case of sound wave. Let us assume that there is a person who is standing here. Here we are having a person. He is standing here. He is at rest. And there is a car approaching him. So there is a car approaching him towards the person. As the car is coming towards this person, what this person will see and he will hear that as the car is approaching him, the sound of the horn of this car will be increasing. Whatever the sound the car is producing, as the car is approaching this person, initially the intensity of sound will be increasing. Similarly, when the car is receding away, when the car is going away from this person, what he will see? He will see that, he will observe that, he will hear that the intensity of sound is decreasing. So as the car is approaching him, the sound intensity is increasing. As the car is leaving him, the sound intensity is decreasing. So definitely there is change in frequency of the sound. That apparent change in frequency of the sound due to relative motion between source and observer is called as what? It is called as Doppler effect of sound. So see here. So what is the definition you can write? You can write the definition as the apparent change in the frequency of sound, due to relative motion between source and observer. So this is the first statement you are supposed to write down in Doppler effect. What is the statement? Apparent change in the frequency of sound due to relative motion between source and observer. Again, this shift in the frequency is called as Doppler shift. It's called as what? Doppler shift. Here we'll be having two cases. The first case is, in this Doppler effect, we'll be having two cases. The first case is source is in motion. Source is in motion while the observer is at rest. Observer at rest. And the second case will be observer in motion. Observer in motion while the source is at rest. While the source is at rest. So here we'll be discussing the first case. What is that first case? We'll be discussing the first case. That is what? Source is in motion and observer is at rest. Because this is very important question when if you are writing the annual examination. So what is the question? In the examination, you can get the question as what is Doppler effect? Obtain the expression for apparent frequency when the source is in motion and observer is at rest. So let us obtain the expression for that. So what is the condition which we are going to discuss now? We are going to discuss the condition of source is in motion and observer is at rest. Observer is at rest. We are going to discuss regarding this condition. What is that? Source is in motion and observer is at rest. So let us consider a source observer here. So this is my observer. You are supposed to draw the diagram also. This is observer. Whether it is resting or in motion, he is at rest. So at some distance L, here I am having a source. So here I am having a source S which is in motion. So there is a source which is at a distance L from the observer. This total distance is how much? The total distance is L. From here to here, the distance is L. This distance is L. Now carefully see here. Tell me whether the source is at rest or is in motion. The source is in motion. Now while the source is moving towards the observer, the source is moving towards the observer. What is the condition I am considering? Source is moving towards the observer. Towards the observer. See here. Now, while moving towards the observer at initial time, at time t is equals to 0. At time t is equals to 0, what the source will do? Source will emit one sound wave. Assume that at time t is equals to 0, the source is emitting one sound wave, which is reaching the observer. So at time t is equals to 0, source emits a sound wave which reaches the observer at time t1 is equals to Cm. Now at time t is equals to 0, the source is emitting a sound wave. Now the sound is moving towards what? Observer. Now how much distance he is covering? He is covering a distance of L. With how much velocity the sound wave is moving? Let us assume that the sound wave is moving with a velocity of v. What does v represent? Velocity of sound. Velocity of sound. So see here, at time t is equals to 0, the source has emitted a sound wave. Now this sound wave will reach the observer at how much time? It will reach the observer at time t1 is equals to, you know that what? Velocity is equals to distance by time. Time is equals to what? Distance by velocity. So this will become what? How much distance the sound wave has traveled? L distance the sound wave has traveled divided by how much time I am with how much velocity the sound is moving with velocity v. So this will become T1 is equals to L divided by V. I hope you understood this. At initial time t is equals to 0, the sound wave is moving toward the observer. While moving at time t is equals to 0, the source has emitted the sound wave which is reaching the observer at how much time? T1 is equals to L by V. Now assume that the source has moved from this particular distance, from this particular point to this particular point. Then the distance moved by the source can be given as what? E is equals to Vs into t, that is velocity of source, and the time taken is t. So what is the leftover distance? The leftover distance is L minus Vs into t. I hope you are getting this. Initially, at time t is equals to 0, the source has emitted a sound wave which has reached the observer at how much time? T1 is equals to L by V. Now, source is also moving. Let us assume that the source have moved a distance of how much? Vs into t. Now, the source is here. Now, the source is here. Now, let us assume that the source is again emitting a sound wave from here. The source is again emitting a sound wave from here. So, what will be the time taken? The time taken will be given as T2 is equals to, already the source has traveled the distance from here to here in time T, plus what is the distance left out? The distance left out is L minus VST, L minus VST divided by what is the velocity of sound? Velocity of sound is V. So this is at time T2. The source initially at time T is equals to 0 has emitted a sound wave. Now the source has moved from this particular position A to particular position O. Again at O, the source is emitting another sound wave which is reaching the observer at how much time? T2 is equals to T plus L minus VST divided by V. So I'm going to determine the time interval. So I can write time interval delta T as what I can write? What is the value of T2? T2 minus T1. What is the value of T2? It is T plus L minus VST divided by V minus T1. What is the value of T1? L divided by V. If you solve this, what you will be getting? Delta T is equals to T plus L by V minus VST divided by V minus L divided by V. So this L divided by V, this L divided by V will get cancelled. So here you are able to see T and G here. So I can take T common. If I take T common, what this will become? This will become T of 1 minus Vs divided by V. If I solve this, this will become T of V minus Vs divided by V. But what we are supposed to obtain? We are supposed to obtain the frequency. What is the relation between time period and frequency? We know that frequency is inversely proportional to time period. We know that F is equals to what? 1 by T. So I will write this, invert this thing. What it will become? It will become 1 by delta T is equals to 1 by T of what this will become? This will become V divided by V minus Vs. V divided by V minus Vs. Now this frequency is called as apparent frequency. F apparent is equals to F real into V divided by V minus Vs. This is the apparent frequency of a source when the source is moving towards what? When the source is moving towards observer. Source is moving towards observer. Towards observer. So what has happened? Initially, the source is moving towards the observer at initial time T is equals to 0. The source has emitted a sound wave which has reached the observer at how much time? T1 is equals to L by V. After time, at one particular time T, the source has moved a distance. How much distance? D is equals to Vs into T, where Vs represents what? Velocity of source. Now, at one particular distance at position O, the source is again emitting the second sound wave, which is reaching the observer O at time T2 is equals to T plus L minus VST divided by V. So if I find the time interval, I will be getting this equation, but I am supposed to obtain what? I am supposed to obtain the expression for apparent frequency. So what is the relation between frequency and time period? It is given as F is equals to 1 by T. So what will be my answer? My answer will become what? F apparent is equals to F real into V minus V, V by V minus Vs. Let us assume that the source is moving away from the observer. If the source is moving away from the observer, source moving away from the observer, away from observer, then what will be the expression I will be getting? I will be getting the expression for apparent frequency as F apparent is equals to F real into V divided by V plus Vs. So for source moving away from the observer, what is the expression for apparent frequency I'm getting? F apparent is equals to F real into V by V plus Vs. When the source is moving towards the observer, what is the expression I'm getting? I'm getting the expression as what? F apparent is equals to F real into V divided by V minus Vs. So this is the most important question from wave chapter. What is that? Define Doppler effect. Next, you are supposed to obtain the expression for frequency of sound wave when the source is in motion and observer is at rest. I hope you understood this answer. If we are done with this answer, let us move on to the next question. Next question we are going to discuss is organ pipes. Next question which we are going to discuss is what? It is organ pipe. Organ pipe. In this organ pipe, we'll be having two types of pipes. One is called as open organ pipe. Open organ pipe. And the next one will be called as closed organ pipe. Closed organ pipe. So what is actually the meaning of organ pipe? It is nothing but a cylindrical tube whose length is very large when compared to its diameter, and it is used for producing musical sound. Okay. So what is organ pipe? It is nothing but a cylindrical tube whose length is very large when compared to its diameter. Why will be using this organ pipe? We'll be using this organ pipe for producing the musical sound by the use of air. So how many types of organ pipes we are having? We are having two types of organ pipes. One organ pipe is called as what? One organ pipe is called as open organ pipe, and the other organ pipe is called as what? It is called as closed pipe. So let us consider this to be an organ pipe. If both the ends are open, if both the ends of organ pipe are open, so here, this is one opening, and here, this is one opening. If both the ends are open, if both the ends are open, then this type of organ pipe is called as what? This type of organ pipe is called as open organ pipe. Open organ pipe. If I consider another organ pipe, something like this, whose one end is open, whereas the other end is closed. The other end is closed. So an organ pipe whose one end is open, one end is open, and other end is closed, then this type of organ pipe is called as what? This type of organ pipe is called as closed organ pipe. Closed organ pipe. So see here. So what is the meaning of organ pipe? It is nothing but a cylindrical tube whose length is very large when compared to its diameter. Why will be using the organ pipe? For producing musical sound notes by the use of air. Air will be sent into this organ pipe. Due to that, what will be happening? Due to pressure difference, the vibrations will be there, and due to that, we will be getting some sound here. So see here, let us understand few terminology before starting the answer. Here we will be getting notes and antinodes. Here we will be getting what? Notes and antinodes. Antinode. What is the meaning of node? Node means a position where amplitude of particles is zero. Amplitude of particles will be what? Particles will be equals to zero. And what is the meaning of antinode? Antinode represents a point where amplitude is maximum. Amplitude is maximum. So node is a point where the amplitude will be zero and antinode is a point where the amplitude will be maximum. Another important thing for you to remember is always at open end, always at open end, what will be formed? Antinodes are formed. Antinodes are formed. Here I am not explaining how those antinodes are formed, why the antinode is forming only at open end. All those things are not necessary for writing in the examination. You are just supposed to know the definition, and he will be asking whether in the examination he may ask what is open pipe, often the ratio of frequency in case of open pipe. Or he will be asking a question, what is a closed pipe, and often the ratio of frequency in case of closed organ pipe. So just you are supposed to remember only this thing. You are not supposed to know for writing the examination. You are not supposed to know why the antinodes are always forming at open end, why nodes are forming at closed end, etc. So see here, always at open end what are formed? Antinodes are formed. Similarly, always at closed end, what will be formed? A node will be formed. Node will be formed. So remember this. At open end, what will be formed? At open end, antinodes are formed. At closed end, what will be formed? Node will be formed. Now let us enter into the answer. We are first going to study about open organ pipe. First, we are going to study about what? Open organ pipe. So what I said, what is the definition for open pipe or open organ pipe? It is an organ pipe whose both ends are open. So let me consider one organ pipe. This is my organ pipe whose both the ends are open. Whose both the ends are open. So what I said that always at open end what will be formed? Always at open end an antinode will be formed. Here also open end is there. Here also an open end is there. So see here, what will be the first fundamental frequency here? Here I am having open end. So here we'll be having what? Maximum displacement or minimum displacement? Here I will be having maximum displacement. At maximum displacement, which region will be formed? Antinode will be formed. So my pattern for the diagram or wave pattern will be something like this. See here antinode is formed. In between them, the particle's displacement is zero. This point is called as what? This point is called as node. This point is called as node. Again, what is there here at open end? What we are getting at open end? Again, I am getting what? Antinode. So I hope everyone know the distance between antinode and node. What is the distance between antinode and node? It will be lambda by 4. And what will be the distance between node and antinode? Again, it will be lambda by 4. So I can write down the length of this organ pipe as what? Lambda by 4 plus lambda by 4. So what it will become? It will become L is equals to 2 into lambda by 4. So 2 ones and 2 get cancelled. So we are left with what? Lambda by 2. From here I can write lambda is equals to 2L. What I can write? I can write lambda is equals to 2 into L. But we are supposed to obtain the expression for frequency. What is the formula for frequency? We know that the formula for frequency is given as F is equals to V divided by lambda. I am writing this as the first condition. F1 is equals to V divided by what is the value of lambda you got? 2L. This frequency is called as fundamental frequency. What is the name of this frequency? This frequency is called as fundamental frequency. This frequency is called as what? It is called as fundamental frequency. How many antinodes are here? We are having 2 antinodes. How many antinodes here we are having? We are having 2 antinodes. 2 antinodes. And how many nodes we are having? We are having only one node. We are having only one node. Let us determine the first overtone. Determine the first overtone. What is the meaning of first overtone? Any frequency higher than fundamental frequency is called as first overtone. So I am considering again the same organ pipe. Again I am considering what? Same organ pipe. So here I'm trying to get how many nodes? I'm trying to get two nodes and three antinodes. How many nodes? Two nodes and three antinodes. Always at open end, what will be formed? Antinode will be formed. Always at open end, what will be formed? Antinode will be formed. So see here, the inside waveform will be something like this. See, here what is this point? This point is called as node. What is this point? This point is called as node. So see here, I hope everyone know what is the distance between antinode and node. The distance between, I'll write this here. How many nodes are there? Two nodes. And how many antinodes? Three antinodes. So here it will be antinode only. See here. What is the distance between antinode and node? It will be lambda by 4. And what is the distance between node and node? The distance between node and node will be lambda by 2. And what is the distance between node and antinode? It will be lambda by 4. So what is the total length of this organ pipe? Here we will be getting L is equals to lambda by 4. I can write what? L is equals to lambda by 4 plus lambda by 2 plus lambda by 4. So here I can write L is equals to lambda by 2 plus lambda by 2, because we know that lambda by 4 plus lambda by 4 is nothing but again it is lambda by 2. So what this will become? L is equals to 2 lambda by 2. From here I can write lambda is equals to 2L divided by 2. Next, again, what we are supposed to find? We are supposed to find the frequency. What is the formula for frequency? F is equals to V divided by lambda. This is the formula for frequency. So I can write here F2 is equals to V divided by, what is the value of lambda I got? 2L divided by 2. So this will become what? This will become 2V divided by 2L. So I can write this one as F2 is equals to 2 into F1, because what is the value of F1? F1 ki value is V by 2L. Again, I am getting here V by 2L. Here also I am getting V by 2L. So I can write F2 is equals to 2F1. And this frequency is called as what? Fundamental or first overtone. This is called as what? First overtone. First overtone. Or you can also call this one as what? Second harmonic also. Let us do one more thing. Let me try to get here how many nodes? Here already I got one node. Here it was one node. Here it was two nodes. And here I am trying to get how many nodes? I am trying to get three nodes. How many nodes? I am trying to get three nodes. See here. Again, I am taking the same organ pipe. Open at both ends. We know that at open end, what will be formed? Antinodes are formed at open end. So how many nodes I am supposed to get? I am supposed to get three nodes. See here, the diagram will become something like this. It will become something like this. Here, what will be formed? Here, a node will be formed. What will be formed here? Here, a node will be formed. What will be formed here? Here, a node will be formed. Now, what is the distance between antinode and node? The distance between antinode and node will be how much? It will be lambda by 4. And what is the distance between node and node? It will be lambda by 2. And what is the distance between again node and node? It will be again lambda by 2. And what is the distance between node and antinode? It will be lambda by 4. So what will be the total length here? Here the total length will become L is equals to lambda by 4 plus lambda by 2 plus lambda by 2 plus lambda by 4. So what will be L? Lambda by 4 plus lambda by 4 will become lambda by 2 plus lambda by 2 plus lambda by 2 will become lambda. So what will be the value of L? L will become 3 lambda divided by 2. From here I can write lambda is equals to 2L divided by 3. What I can write? Lambda is equals to 2L divided by 3. Again, what is the formula for frequency? F is equals to V divided by lambda. So what is this? This is called as second overtone. What we are writing regarding second overtone. Second overtone. So here we are getting the frequency as F3 is equals to V divided by, what is the value of lambda I got? 2L divided by 3. So this will become 3V divided by 2L. So I can write F3 as F3 is equals to 3 into F1. So this process goes on like this only. So I can finally write one expression. What is that expression? The ratio of frequency is given as F1 is to F2 is to F3 is to so on. This will be equals to what? This will be equals to 1 is to 2 is to 3 and so on. So this is the ratio, frequency ratio in case of what? In case of open organ pipe. So what we did, we have considered an organ pipe. What is the meaning of organ pipe? Organ pipe is nothing but is a cylindrical tube whose length is very large when compared to its diameter. How many types of organ pipes we are having? We are having two types of organ pipe. One organ pipe is called as open organ pipe and the other organ pipe is called as closed organ pipe. So in an organ pipe, whenever you are sending a sound wave, that sound wave will get reflected from the other end. The incident sound wave and the reflected sound wave will superimpose and form what is stationary wave. We'll be getting stationary wave, both in case of open pipe as well as in case of closed pipe. So see here, at open end, what will be formed? At open end, antidote will be formed. And at closed end, what will be formed? At closed end, a node will be formed. So just so we have seen the case of frequencies in case of open organ pipe. At always at open end, what will be formed? Antinode will be formed. And what is the formula for fundamental frequencies in case of open pipe? In case of open pipe, fundamental frequency is how much? It is V divided by 2L in case of open pipe. And what is the frequency ratio we are getting in an open pipe? The frequency ratio in case of open pipe is how much? 1 is to 2 is to 3. I hope you might have already studied this answer. See, what is the ratio in case of open pipe? Frequency ratio in case of open pipe? 1 is to 2 is to 3. Now let us move on to the next organ pipe. What is the next organ pipe we are having? Closed organ pipe. What is the next organ pipe we are having? Closed organ pipe. So I'm considering second one. Closed organ pipe. Closed organ pipe. Again, what I will be doing? I will be obtaining the frequency ratio in case of closed organ pipe. Now see here. Let me consider one closed organ pipe. This is my closed organ pipe. What is the meaning of closed organ pipe? One side will be open and other side will be closed. So always at open end, what will be formed? Always at open end, antinode will be formed, and always at closed end, what will be formed? A node will be formed. So I'll be getting a waveform something like this, sound waveform something like this. Open end, always an antinode is formed, and at closed end, what will be formed? A node will be formed. My sound wave diagram inside an organ pipe will be something like this. Now we know that the point where the amplitude is 0 is called as which point? It is called as node. So what is the distance between antinode and node? It is, okay, I will initially consider only one sound wave. This will become again first harmonic. So let me consider only one sound wave. Consider only one sound wave. See here. Let me consider at open end what I am getting. At open end, I am getting antinode. And at closed end, what I will be getting? I will be getting a node. So see here. This is the waveform which I got in case of open organ pipe. Sorry, closed organ pipe. Here what I am getting? I am getting antinode. So what is the distance between node and antinode? Here it will be lambda by 4. So what is the length I can write? I can write length L as, I can write length L as L is equals to lambda by 4. From here I can write lambda is equals to what? 4 into L. So what is the formula for frequency? We know that the formula for frequency is given as F is equals to V divided by lambda. And what is the value of lambda we got? The value of lambda we got is 4L. So here the frequency F, what is given as V divided by 4L. And this frequency is called as which frequency? This frequency is called as fundamental frequency. Fundamental frequency. In which case? In case of closed organ pipe. So how many nodes and how many antinodes here we are having? Here I am having one node and one antinode. Here I am having one node and one antinode. Let us consider two nodes and let us see what will happen. Here again I am considering the organ pipe. Now this time I am considering two nodes and two antinodes. So this is closed organ pipe, which is open at one end and closed at other end. So always at open end what will be formed? Always at open end antinode will be formed, and at closed end what will be formed? Node will be formed. So the diagram will become something like this. See here, at this point the amplitude is 0. Here we will be getting node. So what is the distance between antinode and node? It will be lambda by 4. And what is the distance between node and node? It will be lambda by 2. So total length will become what? Total length will become lambda by 4 plus lambda by 2. So if I write this will become what? Lambda plus 2 lambda divided by 4. So this will become how much? L is equals to 3 lambda by 4. This is given as what? Lambda is equals to, what I can write here? Here I can write lambda is equals to 4L divided by 3. Lambda is equals to what? 4L divided by 3. So the formula for frequency will become what? F is equals to V divided by lambda. That is nothing but F is equals to V divided by, what is the value of lambda we got? 4L divided by 3. So from here I can write F is equals to 3V divided by 4L. That is nothing but F is equals to 3 times of fundamental frequency. This is sometimes called as third harmonic. What is this called as? This is called as third harmonic. Or you can also call this one as what? Second overtone also. You can also call this one as what? Second overtone. So what is the ratio of frequency here? Here this is the F3 is equals to how much? 3 times of F1. That is nothing but third harmonic is equals to what? 3 times of first harmonic. So let me consider one more case here. How many antinodes? I mean, how many nodes we got here? 2 nodes. Let us take 3 nodes and determine the frequency. Again, I am taking an organ pipe. But this time, I will try to get 3 nodes. Here. Always at closed end, what will be formed? Always at closed end, node will be formed. And open end, what it will be formed? Antinode. So at this point, what will be formed? Node. At this point, what will be formed? Node. So what is the distance between antinode and node? It will be lambda by 4. And what is the distance between node and node? It will be lambda by 2. And again, what is the distance between node and node? Again, it will be lambda by 2. So what is the total length I will be getting? The total length I will be getting is L is equals to lambda by 4 plus lambda by 2 plus lambda by 2. So what will be the value of lambda by 2 plus lambda by 2? It will become lambda. So what will be the value of L? L will become 5 lambda by 4. And what will be the value of lambda? Lambda will become what? 4L divided by 5. 4L divided by 5. Now let us determine the frequency. What is the formula for frequency? I know that the frequency is given as what? F is equals to V divided by lambda. That is nothing but V divided by, what is the value of lambda? 4L divided by 5. 4L divided by 5. So from here I am getting F5 is equals to 5V divided by 4L. That is nothing but I can write F5 is equals to 5 into F1. So this is called as fifth harmonic. What is this? This is called as what? Fifth harmonic. This is called as what? Fifth harmonic. So what is the ratio of frequency in case of closed pipe? The ratio of frequency in case of closed pipe is given as what? 1:3:5 so on. If I take another organ pipe and if I try to get 4 notes again, then what will be the next frequency? The next frequency you will be getting will be 7. So I hope you understood this LAQ. So in today's class, what we have discussed regarding Doppler effect. Doppler effect in case of sound. What was the definition for Doppler effect? The apparent change in frequency of sound wave due to relative motion between source and observer. How many cases here we are having? We are having 2 cases. What is that? Source is in motion and observer is at rest. And what is the next case? Observer is in motion and source at rest. Next, what we have discussed? Next, we have discussed regarding open pipe and closed organ pipe. So here one more question is there. I want you to go through that question. What is that question? Formation of stationary wave in a string. What is the next important question from wave? Formation of stationary wave in a stretched string. So here you are supposed to obtain again the same thing. Whatever we did in open pipe and closed pipe, here you will be determining the frequencies. In case of stretched string, you will be writing the answer. So here you will be getting the frequency something like this. F is equals to 1/2L under root T divided by mu. Again, you are supposed to write down the loss of transverse vibration. So what will be the loss of first law of transverse vibration? Frequency of a stretched string is inversely proportional to the length of that wire. Frequency of stretched string is directly proportional to the square root of the tension. Frequency of stretched string is inversely proportional to the linear mass density of that particular wire. So I want you to go through this answer. What is that question? Formation of stationary wave in a stretched string. What will be the frequency formula? The frequency formula will be F is equals to 1/2L under root T by mu. Again, based on this formula of frequency, what you are supposed to write? You are supposed to write the 3 fundamental laws. 3 fundamental laws of the vibration in a stretched string. So I hope you understood today's class. Please go through this answer. These are very easy answers. You might have already studied this answer. So we are done with the LAQ chapter. What are the LAQ chapters that we have discussed? We have discussed regarding current electricity. What was the next chapter that we have discussed? We have discussed regarding nuclear physics. And today we have discussed regarding waves. So if you are done with the first 2 chapters, if you are perfect with the first 2 chapters, definitely you will be able to answer 2, most probably 99.9% you will be able to answer 2 LAQs from this chapter. To be on safe side, if you want to read this waves chapter, you can also read this. Finally, we have already done with the SAQs chapter. What are the SAQs chapters that we have discussed? We have discussed regarding semiconductors. We have discussed regarding atoms. We have discussed regarding electromagnetic induction. We have discussed regarding moving charges and magnetism. We have discussed regarding ray optics. We have discussed regarding wave optics. Further, we have discussed regarding electric charges and fields and electric potential and capacitance. In total, we have discussed 8 SAQ chapters. If you are done with that 8 SAQ chapters, at least you study 6 SAQ chapters perfectly. So by this, we have finished all the LAQs and SAQs of second year physics. From tomorrow onward, we are going to discuss regarding very short answer type questions. Okay. Thank you. We'll meet tomorrow.